I'm sorry.
Huh?
How do you convert?
You don't.
Ratio of moles to
You don't.
So you just do 4.5 divided by 2.
Right.
Don't you ever got to be converted to grams or something?
No.
So you just multiply.
Yeah.
You multiply by
You convert grams to kilograms.
multiply by.
No.
So why is it not
No.
abbreviated as moles?
Look. Okay.
The grams, you know, that's what takes over kilograms? Oh.
Yeah, what is there not to understand about this? So this is what I've been preaching the whole time, right? This is a very good sheet because it tells you what you do, right? Is the definition is determined by the actual dimensional units, right? Because molecules per kilogram, it's like molecular density, right? So if it's molecules per kilogram, right? If you're giving grams in the problem, you got to convert grams to kilograms to get your answer. Then you're done. What's the
Make it sound so simple. It's really not.
It
It's really not
is. It's got
as
it.
simple as you
Well, you know.
But I can lead a horse to water,
They told me.
but I can't make it.
It's like a professor always makes it seem easier than what it really
Right, so can you please go for
is.
Right? It's just locker room talk, guys. That's all it is. I don't know. Hey. Yeah, now's a great time to be a political scientist. It's more fun than being like a real scientist, you know?
So going from grams to kilograms, then you just straight to the left or right?
You tell me. You're going from large to smaller, or small to larger, rather. What do you do?
So you move to the left. Because you're going up, right?
Uh-huh. Small to larger, you gotta move it to the what? To the left, right? Oh man. That's right. What is it? I'm 40. So most of you weren't alive during the Clinton years, were you? Yeah, during Clinton era, you weren't.
Yeah.
But you were like what, 8 or 9 or something? Y'all older than that? I know him. I know he's still. Oh, it's interesting. It's interesting to like see how like people like with time and events and perception of events with time. It's like theory of relativity. You know, did that really happen? Did it even happen at all? Was that even real? Or was that your opinion based on what you perceived of as reality as you knew it, based on the media, right? Because what they do, right, you can actually use the physics, right? You can say, if you have medium, right? What's a media? They call it media, right? See, so you could have like, a television station could be like a medium. Yeah. See? So, depending on the index of refraction and the filter of the medium will determine what color of light you see. So there's no filter, right? And it's transparency, right? Then you kind of can clearly see what's going on behind the scenes, right? So the higher the index of refraction of your medium, which is your television or whatever you get your information from, as the information goes through the medium, it changes trajectory, right? The higher the filter, the less accurate the information is or is not, right? So you can actually model that, and they actually use this stuff in converting information, transferring information. So like Google, what's so awesome about Google is that when you Google reflects back whatever's going on in your mind, right? If you're misinformed, what do you get from Google? This information. Yeah. Isn't that cool? Right? If you're in stuff you're not supposed to be into, it reflects that back too, right? And you go to extreme, then you get a little knock. You're like, everybody, just get it back in the car. Right? So yeah, Google is an awesome medium because it literally reflects back human consciousness based on what's going on in your mind, right? So if you're not interested in anything and you're anti-intellectual, then you have, look on your Google search, there's a lot of anti-intellectual stuff up there.
Is that Francis Bacon here?
I've never heard that.
They call you?
Okay, so like for new one.
Oh, why are you trying to get back to the main message? Why are you trying to mess up my flow? Huh? Why are you trying to focus me in, huh?
I don't mean to be rude, but.
You know what I'm saying? I mean, I'm trying to talk about stuff that has nothing to do with what we're supposed to be doing, and you messing me up.
Okay, so I
Yeah,
wanted to know,
yeah.
they said how many case, calcium chloride, what's that?
Yeah, molality. So molality is defined as lowercase m equal to, what are the units? Moles per kilogram. Okay? So when you do problem number A, right? How many grams of sodium chloride must be dissolved in 225 grams of water to prepare a 0.445 molality solution?
So do you have to find the molar mass of that, or sodium chloride?
No, just find the number of grams. Why you make it difficult? So what do you know?
I know we have.
You know the molality, don't you? You know the molality, don't you?
Yes,
What's the molality?
0.445.
Right, so you say, that's molality, right? So just substitute it in. So I can rewrite my equation as like, I'll don't rewrite it because they're not enough variables. All right, so all I gotta do is just say 0.445 molality equal to, okay, they ask you for the grams, right? Now, extra step is, you got 200. Y'all got issues, man. Y'all got issues.
That's not gonna work.
Uh-oh. There you go. Is that better? You vampires or something?
That actually does help.
You vampires, I don't trust you. All right. 0.44 molality, right? You got 255 grams of water, so you got to use your periodic table, right? So 225 grams of H2O, right? Gives you what? What is it?
You have point.
It's 2
Well, first you got to, first you have to convert it to what?
So you move it, is it 2.25?
It's 255.
Well, they asked you for grams, right?
No,
Oh.
So you got to find the moles, right?
So 225
Change to 225.
grams of H2O equals.
Well, you got to do anything to that
No,
first.
the number's wrong.
255.
255, thank you.
Okay.
255, right? Okay, so you want to convert grams to moles, right?
So you move that to 2.25.
Hmm? Grams of, hold up. I'm doing it backwards. Doing it backwards. Hold up. How many grams? Okay, so you, no, I think it's right. You got 255 grams of water, right? So you convert grams to moles, right? I don't think you have to. You don't have to. I'll show you why, right? Let's try it out. You got, how many hydrogens you got? 2, right? And 1, right? So that's going to give you 1.00 plus what? 1.00 plus 16.00, 18 what? Grams per mole, right?
And then multiply that times 255.
Or
Wait,
divide.
what you do?
Huh?
You found the molar mass?
Yeah, first you need to get how many moles of water is this, right? So now you go to the periodic table. Hydrogen has 1.0 grams per mole. You got 2 of them, right? And oxygen, that's oxygen, right? right? Add them all together, right? I want moles, right? Moles. So what do you get? So I take 18.00 grams per mole, right? So I say 255 divided by 18.00, correct? 255 H2O divided by 18.00 grams per mole, right? The grams cancel, right? What do you get?
14.1, 14.2.
14.2. Everyone agree with that?
Sure.
14.2 moles, right? Now I have my moles here. So I got 0.445 molality equals 14.2 moles over how many kilograms, right? How many kilograms, right? Now, what is molality again? Molality, I can replace this, the units, as moles per kilogram, right? Because it's the same, isn't it? Okay? So now I want to know, what is my mass? Right? I want to know, what is my mass? Okay? So now I get how many kilograms of what? Potassium chloride? How many kilograms do I need to get? Now I cross multiply, right? This is my x, isn't it? That's my x, isn't it? It's just an algebraic problem, isn't it? So now cross multiply, I get 14.2 moles over what? 0.445 moles per kilogram, right? See, that cancels out. See? I get kilograms left over. See, that's dimensional analysis. So you had a problem with this. That means you didn't understand the conversion at the very beginning, the conversion stuff.
So couldn't we have just converted that grams to kilograms in the second one, in that second question on that?
Maybe, have a look at it. All right, so they ask you how many grams, right?
Yeah.
Okay, so 14.2 divided by 0.445, what's that?
31,
Hmm?
32,
Say it again.
32.
So 32.0 kilograms of potassium chloride is how much you have to add. That's what my math is. You see that? Now, they ask you for grams, right? So you move the decimal. Right? You got to convert kilograms. Now you can convert the kilograms to grams, right? Which is what you want to do in the beginning, but you didn't. You got to go through all that first.
Do we
Before-
have to?
Hmm?
Do we have to? Could we just have?
No, you have to, because they ask you for grams specifically.
To kilograms.
They ask you for grams specifically, see? So you got 32.0 kilograms, which is equal to how many grams?
So our
You got-
is
Hmm?
255 grams to kilograms, and then divided that by 0.445.
Because they're two different things. You got grams of water and grams of potassium chloride, right? First, you have to get what the mass of potassium chloride is first before you do your conversion. So don't mix up the water with the potassium chloride. They're two separate things at first, right? You're adding one to the other, right? You're giving one, based on what you're given for one, you got to find the other, right? So what you're trying to do is solve, you're trying to say, that would work if you were adding water to water, wouldn't it?
Yeah.
But there's no reason to do water to water because water is what? Water plus water gives you what? Water, but that's not what we're doing.
So you're trying to find the,
We're adding potassium chloride to what? Water. You see that?
you're just trying to find the grams of potassium chloride.
We add the salt into it.
So we're adding salt, potassium chloride salt to a, what do you call that? A solvent, which is water. Okay, so now you got to convert kilograms to grams, right? So you move your decimal to the what?
Right.
To the right. So 32,
30.
right? Grams equals mass, correct? Or you could say, with scientific notation, 3.2 times 10. How many zeros do I have? 3, 10 to the 3 grams. Equals mass of potassium chloride. Question about that?
Wouldn't it
So you
be
have, potassium.
10 to the 4th?
Yeah. That's correct. 10 to the 4th. Right. Everybody get that? 1, 2, 3, 4. Right. That's for molality. All right, let's try another one.
Wait, but you didn't do the potassium
Oh,
calcium?
that's the KCL. I was trying to figure out what it is.
Oh, never mind.
What are y'all talking about? What are you talking about? What are they talking about? You know what they're talking about?
All right.
It's Captain America over here.
Wait.
Stay out of that man's army. That's my grandmother used to say.
Yeah.
She was like 5'3" or 6 or something. I don't know, whatever it is. Real short. And all of her sons would come home from the military. He's like, I don't trust them, Uncle Sam. Uncle Sam. That's what she said. She cuss him out when they meet him. When she saw him, they'd be in full uniform. She'd cuss him out and then tell him she ain't trust no Uncle Sam. Isn't that awesome? No, ma. You know, like these soldiers. You're like, no, ma, no, don't say that, ma, no. It's Americana, right?
Don't erase it.
You might have any questions?
Don't erase it.
What is to be confused about that? There's nothing to be confused about.
Because they clearly don't explain that you gotta convert all that stuff over there, find the lower man.
You're supposed to know that.
All that stuff.
No. How many laboratories you been through?
All of us are in line.
I took the lab.
Four are in the lab.
See?
Already in
You're supposed to learn this in high school. This is a refresher.
Or are you down to school 10 years past that?
You're supposed to retain it. Aren't you a nurse or something? I don't know. I ain't go to that hospital. You can kill somebody over. You like Michael Jackson. You ain't gonna wake back up.
That was cold.
That's what this is. That's what this is. See, y'all think this is just, this is real. Ask him. He'll tell, well, he won't tell you now.
See, you can't be throwing my game.
He threw himself in like that. He should have stuck with Dr. Sabi. He'd been all right. He didn't want to pay him.
That wasn't his
You don't want to pay Dr. Sabi. You don't want to pay him.
That was his job.
She ain't laughing. She got serious on it. We're going to move on. Moving on. You ought to be finished. You should have had the answer already. You should have had the answer 2 weeks ago. You should have had the answer 2 weeks ago. Huh?
Why do you have 10 to the 4? To the 4. Instead of 10 to the 3rd.
Look, see? 1, 2, 3, 4. 4. Huh? No, you want to be between 1 and 9. When you scientific notation, you need a number to be between 1 and 9. Right? Look, hey, the base number needs to be between 1 and 9, right? So you do, look, hey.
But the base number started at 32.
That's what I'm saying. It needs to be between, for scientific notation, it needs to be between 1 and 9, the base number. 3.2 is between what? That's the base number, see? And so I say, look, 1, 2, 3, 4, 4. Come on, Cap. Come on, man.
I didn't say the L.
Use the L. All right. So what you got? Part B. So now they ask you for the molality. They give you all the other information, and they ask you for molality. They ask you for this in part B, right? Okay. So what is the molality of dissolving 35.2 grams of sodium chloride into 300 milliliters of water. Assume the density of water is 1 gram per milliliter. So, what do we have to do? We have to find what first?
Convert milliliters to liters?
No, absolutely not. Somebody else.
Grams, 35.2 grams.
We need to find that.
You want to find out how many grams of water you have, right? Now, how do you do that?
Convert milliliters to
Y'all keep talking to me. Huh?
Convert milliliters to grams?
But how do you do that?
That's what I'm asking.
Oh, that's you asking me. Oh, okay. Oh, you asking me now.
By assuming the density of water is.
There you go. Use what you're
gram
given.
per milliliter.
Exactly. That's the right way to go. All right. So you're given that density of water is equal to density is mass over volume, right?
Yes.
And of water specifically, it's going to be 1.00 grams per milliliter, correct? All right. And they give you the volume, right?
Yes.
So yeah, okay. And you want to find the mass, right? Okay. So you just say 1.00. See, notice I put in all my units, right? Equals, what's the mass of water? That's what I'm trying to find at first. That's my first step. Over what? The volume is 300 milliliters, right? Okay. So rather than using the periodic table, they give you the density of water to find the amount of grams of water. See, they're asking you to reverse. They give you the problem in reverse, really, and change the number. That's all they've done. All right. Stars and stripes. You play a video game?
So I'm doing that.
All right. So mass, the mass of water, is equal to what? What's 3.00 times 300? What's 300 times 1? I gotta check y'all. I don't know. Y'all acting a little brand new today. I don't know what's going on. All right. 300. So I'm gonna put in all my steps here. Cross multiply, right? What are you gonna get? See, 1.00 grams per milliliter. Milliliters cancel. That gives you what? 300 grams, right? So you should know that, right? That what you were saying, right? When you deal with water, special case, water, all you have to do to convert grams to milliliters is realize that it's exactly the same. That's not like a huge word face like these guys, extremists, they're really eloquent, but they're really saying it's very destructive. And the only answer is complete separation of water and potassium. Yeah, they sell the papers. They don't be saying nothing.
I bought one and I opened it up and
I think it was bee pies you diabetes, right?
I will take the
Bee pies? I think one day I'm gonna join for one day just so I can sell bee pies. Just so I can. Any of them. I can sell bee pies. I'm gonna join for one day and then quit.
What are you enjoying?
I'm on camera. I can't go around. So you go through all this. This is like a laboratory experiment, right?
Yes.
Okay, all right, great question. All right, listen up. The same answer as in the last problem, right? They give you how many milliliters of water, right? Okay, all right. But they're asking you for the molality of the solution, all right? So you're given the water information, okay, right? And you're given how much salt, right? Now they're asking you for the relative molecular concentration per kilogram, see? So in order to get that, you have to make that conversion. Hold up. Let me
You
see.
need to be 3.52 grams. That was irrelevant.
No, you still need that.
Oh,
I ain't finished yet. I'm trying to slow it down so y'all.
You gotta do the atomic mass of KCl, right?
Everybody get that? Hmm. All right. So potassium chloride again, right? So we do the same thing that we did with water here with the potassium chloride this time, right? Because we're given all the information for the water, but now we need more information for the potassium chloride, right? So what's the atomic mass of potassium?
39.
So potassium is 39.1 grams per mole, right? And what about chlorine?
35.5.
It's kind of high, isn't it? 35 point what?
5.
5 grams per mole, right? Remember, it's potassium chloride. It's 1-to-1 molarity, right? 1-to-1. So now we add all this, right? So you got 0.6, this is 4, 7 grams per mole. Okay. Now, how do you know where you're going? This is how you know where you're going. See? Because they give you the grams per, well, you had to find it. They give you the potassium chloride, they give you the grams. You got to go to the periodic table, find the grams per mole. That's how you do that, right? Now you can, so you're given the grams. So how many grams of potassium chloride they give you? Was it 35.2? Yeah. So, yeah, 35.2 grams, right? So now, similar to what we did in the previous problem, but we're doing this on the salt this time. You divide 35.2 divided by the molar mass. That's going to give you moles, right? I'll show that to you, right? So this part, right? 35.2 grams divided by what we just found here, right? It's all potassium chloride divided by 74.6 grams per mole, right? What does that give you?
472,000. 0.472.
That sounds right. 0.472, right? Almost 0.5, right? What are the units for that? Grams cancels. See? All right. So now, when I ask that question, if you immediately do not respond out moles, you don't know what the hell is going on. Okay? Right?
So if
Notice, see here? Look. How do I know where I'm going? Right? You don't get this part, I'm going to repeat it several times. You don't get this part, you're going to continue to be lost. See grams here. See, gram, it's your units, not the numbers. If you follow the numbers, you get lost every time. Don't try to follow the numbers. Follow the units. Right? Because I ask you, what unit did I just find? And you don't know, that means you're totally lost. Because when we're doing this together, you should be following the units, not the numbers. So you're trying to, if in your mind you're trying to go, okay, 200 minus 1 plus 2 divided by that, that's nonsense. And you get lost every time. Because each problem is different. And how many different configurations of those numbers can you have? Infinite. Infinite. Right? You'll be confused until you get all the way till you get to organic, probably. But if you listen to what I'm telling you, right? Follow your units. See? Potassium chloride. How much is potassium chloride? 35.2 grams of that. Now I go back to my elements. Go to periodic table. That's for molar mass. What do you use for molar mass? Grams per mole. All right. What am I looking for? I'm looking for molality. What is molality? Moles over kilogram. Therefore, in order to calculate molality, my units have to be what? Moles over kilograms. That's how I know where I'm going. Right? Anybody have questions about that? Kiana?
Yes. So, okay, so I just wanted to know, Like, you see how you have to set it like that right there? I guess I just did it different. So what I did it wrong if I put 35.2 grams times